Welcome to this presentation about the World Health Organization's Health Economic Assessment Tool, HeatR, for walking and cycling. Today we'll share some of our insights about building this tool in R with a shiny user interface. But first, let's start with a brief introduction about the context. HeatR is a freely available online calculator for the quantification of health impacts, both the risks and benefits, from walking or cycling. It also includes assessments of carbon emission reductions, as well as an economic valuation of impacts. It is used to assess various policies or projects in the transportation, urban planning, or health promotion domains, with the goal to provide key information to decision-makers. As such, the goal of the tool is to make the often highly favorable health benefits of walking and cycling measures visible to urban and transportation planners who may not have health on the radar. The tool hence aims to increase the consideration of health benefits in transportation appraisals, which often use monetized impacts and benefit-cost ratios to inform decisions. To pursue this goal, HeatR adheres to some core principles. Aside from its rooting in robust scientific evidence, the strong emphasis of user-friendliness is worth pointing out. HeatR is intended to be an entry-level tool, often used as a conversation starter, or to get a foot in the door. It builds on a relatively simple model and aims to impose minimal burden on its users in terms of required expertise and data requirements. HeatR is targeting an audience without health expertise. The main groups of interest are transportation planners, decision-makers and their staff, advocates promoting health and/or active travel, among others, and may include educators and researchers alike. The main question HeatR answers is, if X people walk or bike an amount Y, what is it worth in terms of impacts on health, such as mortality, and carbon emission reductions? HeatR applies a comparative risk assessment approach. Basically, the situation for the reference case is compared to the situation of the comparison case. The key information that is different between the two cases is the level of active travel, walking and/or cycling, but other differences, including population size, mortality risks, and motorized modes, among others, may be considered too. This difference in active travel translates into a change in mortality based on the underlying scientific evidence from epidemiologic studies. We refer to this impact on mortality as premature deaths avoided. You can think of it as preventable by active travel, or attributable to active travel. To inform the model specifications, the users first have to provide information about their use case, then provide inputs on walking and cycling, and additional details as they desire. The tool complements user inputs with background data and default assumptions as needed and calculates impacts through the four main pathways, namely physical activity, exposure to air pollution while walking or cycling, crash risk, and carbon emissions. The impacts are monetized using value of statistical life and social cost of carbon. Before we move on to the more technical contents of this presentation, I would like to point out that HeatR is a highly collaborative project that has been supported over many years by dozens of experts in the field and sponsored by numerous governmental agencies and research projects. Now I would like to focus on technical aspects of HeatR. During this part, we will touch the following list of subjects. First of all, I would like to outline the main architecture of HeatR. Secondly, data, challenges we faced and lessons learned. UI, explanation why do we like R6 package. Also, I will talk about shiny extensions that we made. Then I would like to present two HeatR packages that were created during the development of our tool and which are actively used in production, Translator and Templater. The second one allows us to construct HTML templates with the support of locales. A few words of introduction to the world of HeatR architecture. The HeatR project consists of three components: data, model, our HeatR package, and UI, build on the top of shiny package. Each part uses different set of R libraries to face challenges of a particular stage. HeatR package is not publicly available. We plan to release this as an open source package when it is ready. As you can notice on the slide, there is a feedback arrow from UI to the model, as our web application pre-fills some web application inputs with available data, which depends on the specified assessment constructed via UI. In other words, UI application queries HeatR model about data for particular scenario. From our perspective, the most important parts are data and model. UI is important in a way to keep consistency within business logic and to collect data properly. Trustworthy and reliable results are the most important expected outcomes of our work. Therefore, UX of UI suffers the most as it has low priority. We are aware of it and we are planning changes in the near future, but it is not top priority task to get super fancy UI at the expense of correctness of the results. It is possible to run heat assessment without UI. In this case, only data and model parts are used. For example, through our API HeatR as a service, abbreviated HAS. This is not yet widely available. The data used within Heat comes from many sources, WHO, WB, UN, etc. Additionally, we allow to carry out assessments on different geo levels, like country, province, county, voivodeship, cities. Challenges we faced: combine data from different sources, having different formats like CSVs, APIs, spreadsheets, units, but also using different geographical names. The mentioned geo levels are an example for a tricky task. This may sound easy in theory, but in practice it is not, as following famous quote, "In theory, theory and practice are the same. In practice, they are not." Why? This is another item from the list of falsehoods programmers believe in. As you probably know, matching the names of countries should not be that complicated, as a list of countries is more or less constant and commonly available using a unified set of names. Still, there are some nuances. The best option to solve this problem would be the usage of some kind of standardized names. You may say ISO 31661 Alpha 2. But here, our specification plays its role. Do you know what might be the issue here? Read.cssv default na.string setting, which is na value. Now please compare this with the list of ISO 31661 Alpha 2. This is the reason why we use ISO 31661 Alpha 3. And if there is a dataset with Alpha 2, we change this immediately, taking into account default NA, strings value. Country names, however, are nothing in comparison to sublevels. Here, with every step, every deeper step into administrative level of each country, excluding well-known cities, becomes a non-trivial task. The differences in names: some databases use diacritics, some not. Some use internationalized forms, some local, including different languages if city, region is multilingual. Sometimes, there are inconsistencies within official administration structure, like special character of capital cities or special regions. Fortunately, we dealt with all mentioned challenges successfully. Key role of achieving this is a proper set of R packages used. Therefore, we use QoS package, which helps us to read big files quickly. Thanks to data table package, we can play with our algorithms matching geographical names on many levels. And of course, we use packages from the tidyverse. But to be able to combine all datasets which operate on the different geographical names, but also to satisfy main goal, which is reduction of data errors to the lowest possible level, we created workflows thanks to Target's R package. On the slide, there is excerpt from our data workflow. The core element is name matching step, as it is used in every dataset. Moreover, to test processed data, a HeatR package is used. Sometimes it is difficult to create comprehensive tests for particular dataset processing, but we encourage you to have something, even simple verification. For example, simple check whether number of input rows equals number of processed rows, like list of countries, can help you to detect trivial issue like mentioned earlier issue with Alpha 2 versus Alpha 3 codes. On the slide, there is example of a HeatR test that we use to conduct data integrity checking. Here are our recommendation regarding data. Use Target's R package to get reproducible, standardized results and to unify approach. Use a HeatR package to test. Even simple tests can help when you don't expect this. From our perspective, the most important role for UI is to keep consistency within business logic and to collect data properly. Trustworthy and reliable results are the most important goals. We decided to use our Shiny framework to build our web application. Almost all Shiny inputs in Heat are generated from spreadsheet dynamically. Of course, we use own dedicated parser and code responsible for caching to reduce significantly time needed for each start of the web application. At some point, we noticed that generic Shiny inputs are not enough. Therefore, we refactored and wrapped generic Shiny inputs using R6 classes. The huge benefit of using inheritance provided via R6 package is that we can only modify method field, which are different in particular type of input, R6 class. In other words, unification of the interface, more examples later, is what we reached. As mentioned earlier, this approach allows for easy modification of generic Shiny inputs. For example, we inject HTML into inputs to add extra functionalities, for example, tooltips. On the right, there's an example of extra content injected into generic Shiny input. And another example of our extensions, which were easily introduced by using R6 classes, is our own authored system called Additional Data. Additional Data feature allows to conduct validity checks, warn, or block some actions if tests fail, and extra definable events, including ways to pre-fill input data with predefined values. On the right, there is an example of syntax of Additional Data feature. All actions are executed on client side, JavaScript, reducing server, UI exchange. Important is that we can use JavaScript Shiny syntax inside our Additional Data feature, boosted with an extra functions. Now, I would like to show you a short video presentation of Additional Data. Consider usage or R6, OOP approach. Maybe in your case, it would be beneficial as it is in Heat. If you decide to play with Shiny generic inputs, please examine HTML structure as not all inputs are the same. For example, selectize input. Unfortunately, we don't plan to release Additional Data feature as a publicly available package in comparison to the tool from the next slide. We decided to create own package to handle translations. All texts are translatable, but not to process translations. For that, we use something different. There are packages offering this functions, that is I18N approach, but each available at that time had own limitations or features we were not interested in. This is the reason why we decided to create our own package to handle translations of multilingual applications, stored as CSV files. The package with tailored functions that are the results of the experience gathered during the development of our production applications. Before we go into details about Translator, short story. Do you know how one character can cause many hours of debugging? Line endings. This is the answer. If you work in an environment in which different operating systems are used, therefore different line endings appear, you might face issue as we did. English texts are used in our case as a key to find translated text in CSV files. If source and translated files are processed on different operating system, different line endings are used in saved files. At the first glance, during debugging, values in both files with EN texts are the same, so you decide to check the R code to find the reason why these texts do not match. Then you notice, yes, texts are almost the same. The difference is line endings. You can notice this when length of text is checked or during inspection of raw format. To avoid this kind of issues, not only in our translator package, by default, we set unify line endings parameter as true, but also during processing of any text file, we unify line endings at any stage of processing. Mentioned earlier, unify line endings parameter, but also translator is expected to always return something, character string. Maybe this is obvious, but you have to figure out how to handle cases in which you don't have particular translation versus you want that particular translation is empty intentionally. Here's the description of the full logic behind translator and how we address this kind of issues. Additionally, we also added method, which allows to pass an additional filter so that subset of translations are returned. We use this to send only subset of translation to UI when not the whole set with all translations is needed. Remember about line endings, different operating system can produce different line endings in saved files. Translator doesn't need Shiny package. It can be used as normal R package. This was one of the reasons why we decided to create our own package, as all available at that time were more focused on web applications. Yes, translator package would be open sourced in the near future. You can speed up this process by sharing your interest with us via email. The last missing piece of our Today Heat story is a package that we created to reduce editorial typos and mistakes in texts used in user interface part. Moreover, we wanted to address our desire to simplify complexity of texts, which are the results of the possible combinations of the assessments scenarios. We achieved this by creating package inspired by Nunjucks and Jinja. Templater, this is the name of our package, allows to create condition templates, with HTML content in our case. We use it also in a template being the source of PDF export text. We can now, more or less, use the same HTML template as we use for the results. This is a huge benefit in comparison to the previous solutions that we used before. Last but not least, Templater has built-in support for locales on Templater level, not within R session. Presently, ifs family constructions, using R conditions, including nested ifs, are handled. Of course, this is possible to execute R code parts, including functions responsible for locale-related formatting of numbers in relation to selected locale. Locale-related functions are important in a sense that it helps us to produce text with proper locale-related decimal and thousand separator. We used it also in charts to present nice unit formatting. It is worth mentioning that locale support happens on Templater level, not within our session. At some point, we decide to rewrite Templater's component tokenizer in C++, gaining the huge reduction of the execution time. In combination with translated text, using mentioned earlier translator package, we are able to present locale-aware text in HeatR application. Presently, only output values are processed. Shiny inputs are not handled yet. We use this widely in the production, including charts unit formatting of the big numbers, PDF exports, and all texts inside Heat application. This is still early version. There are many planned functions. For example, setup process is complicated, mainly due to the needed operating system libraries needed by Templater. Now, I would like to present video with Templater playing the main role so that you can touch the Templater features. Here's an example of a simple template, more complex with nested ifs. And locals. Example of locales in UI decimal and thousand separator. Also, nice numbers. In summary, just 3 ideas. If you are not satisfied with the execution time of your R function, please consider C++ version to speed it up. Templater doesn't need Shiny package. It can be used as normal R package. Nevertheless, currently, we used it to generate HTMLs mainly. To be able to process plain texts smoothly, additional development steps are needed. Yes, Templater package would be open sourced in the near future. You can speed up this process by sharing your interest with us via email. Thank you very much for your time. If you have any questions, please don't hesitate and reach us via email.